Hello, everybody. We are the Biomass Energy Utilization for Manufacturing Facilities. My name is Ethan Bumgarner.
I'm Spencer Chandler.
And I'm Julian Saninocencio.
So, what is biomass? Biomass refers to organic materials from living or recently living organisms, like plants, plant-based materials. It is also a renewable energy source used for heating, electricity generation, and biofuel production. Biomass includes various materials such as wood, crop residues, and organic waste. The energy in biomass derived from the sun through photosynthesis is released when it undergoes processes like combustion. In 2022, biomass accounted for 5% of the total U.S. primary energy consumption. It is equal to about 4.9 quadrillion British thermal units. So one of the ways biomass is used is combustion. Combustion is one of the most commonly used technologies for biomass fuel. Biomass is burned to produce heat, steam, and electricity. Biomass boilers are commonly used in this method, delivering thermal energy in manufacturing facilities. And here is a video explaining combustion.
The plant supplies the district with heat and feeds electricity into the public grid. As fuel, the plant uses wood chips from the municipality's management of its trees and shrubs. They are delivered in lorries and tipped into a feed system, which in turn feeds the plant. As wood chips are a CO2 neutral, renewable fuel, the plant produces green energy. A chain conveyor transports the wood chips to a furnace, where they're incinerated on a grate under controlled conditions. Incineration produces flue gases of about 1000 degrees C that are led to a steam boiler. In the steam boiler, the flue gases give off their heat and are cooled to a temperature of about 180 degrees C. After going through the boiler, the flue gases are cleaned. The first step is to capture the large particles of ash in a multicyclone. Then a bag filter is used to capture fine ash particles. The dust-free flue gases that come through the bag filter go to a denox reactor where their NOx concentration is drastically reduced. The clean flue gases are now led through a flue gas ventilator to a flue gas condenser. The last remaining energy is extracted from the flue gases by further cooling them to about 50 degrees C. This step significantly increases the plant's efficiency. The clean and cool flue gases are discharged through the chimney. The heat the flue gases have given off in the steam boiler is transformed into high-pressure steam, which is led through a pipeline to a turbine. In the turbine, the pressure and the temperature of the steam are converted into shaft power output that is used to drive a generator. After the turbine, the expanded steam enters a condenser, where it is cooled further and condenses, thus generating heat. The heat released from the steam condenser and the flue gas condenser is introduced into the district heating system by means of pumps. 2 gas boilers can be brought online as backup or to meet peak demands for heat. The electricity generated by the generator is fed into the grid as green energy. If there is no heat requirement from the district heating system, the heat from the steam condenser can be cooled via a cooling tower so that the turbine can continue to operate. The Meerhoven Bioenergy Plant converts sustainable wood chips from Eindhoven municipality into hot water and electricity in a highly efficient and clean way. With the arrival of the bioplant and the supply of renewable heat and green energy, the residents of Meerhoven can turn on their central heating and their lights, knowing that they will be minimizing their environmental impact. This plant contributes to make Meerhoven one of the leading sustainable developments. Technology is the key factor on the road towards a sustainable future.
Another way that biomass is used is through anaerobic digestion. Anaerobic digestion is a process of using microorganisms to break down biomass in the absence of oxygen to produce biogas. This biogas primarily consists of methane and carbon dioxide, and it is used to generate electricity and heat as well as natural gas. Here's a video explaining anaerobic digestion.
The South Campus Anaerobic Digester at Michigan State University aims to reduce odor and emissions from manure, food waste, and biosolids, create a closed cycle for recycling organic material, and generate renewable energy. The digester will use a mix of dairy manure, dining hall food waste, biosolids, which are nutrient-rich organic materials, and other organic material from campus and the greater Lansing area. Once delivered, the food waste and biosolids will be heated at 160 degrees Fahrenheit for 1 hour to eliminate any potential pathogens. The material will then be mixed with manure from the MSU Dairy Teaching and Research Center and pumped into the digester. The anaerobic digester is a sealed, airtight tank which can hold 300,000 gallons. Organic material will be heated to 100 degrees Fahrenheit and will remain in the digester for 20 to 30 days. Inside the tank, mixers in the digester evenly distribute microorganisms. These microorganisms break down the mixture, producing biogas and nutrient-rich digestate. Biogas, which is roughly 60% methane, is a form of renewable energy which will be used to generate electricity. The system will generate enough electricity to offset the MSU Dairy Teaching and Research Center, around 300 kilowatts per hour, with enough left over to help power MSU. The capturing and use of biogas will generate energy, shrink the carbon footprint of campus, and improve sustainability. What's left from the process is digestate, the nutrient-rich mixture that will be held in the final storage tank until it can be utilized. Mixers in the storage tank will minimize settling for the potential 2.7 million gallons of digestate. Any unused biogas can also be stored in the sealed headspace. The nutrient-rich digestate will be used to fertilize croplands or other biological treatment processes to fuel research opportunities. By utilizing anaerobic digestion technology, the organic materials from MSU will become resources. Renewable energy is created while odors are reduced and emissions are eliminated. This project is one example of how Michigan State University is actively working to improve sustainability.
So from this video, you can see that Michigan State University approximately uses 17,000 tons of organic waste per year, including dairy manure, food waste from campus dining halls, and grease from local restaurants. This biogas produced will be used in a combined heat and power system, generating over 2.8 million kilowatt hours of electricity annually.
What does the future hold for biomass? The goal of having a global energy sector to be net zero emissions by the year 2050 has some challenges, but here are some benefits. To prevent deforestation, avoid land conflicts, notably for biodiversity protection, maximize use of surplus materials, to negate excess landfill use, an alternative to fossil fuels, and to increase opportunities for profits. Here are our references.